Welcome back to The Explainer. Today we're diving into a true scientific crime story. A cold case, really, that puts one of history's most brilliant minds under the microscope.
All right, a scientific crime story. This one's a real head-scratcher. We're talking about a clash of geniuses, a pretty shocking accusation, and a puzzle that stumped scientists for, get this, more than 70 years.
So, let's meet our two main characters. On one side, you've got the founder, Gregor Mendel. You probably remember him from biology class, the father of modern genetics, the guy with all the pea plants. And on the other side, we have our detective, Sir R.A.Fisher. Now, this guy was an absolute giant, the father of modern statistics. Two titans in their fields.
So picture this. It's 1936. Mendel has been dead for decades, and then Sir R.A.Fisher, our detective, drops an absolute bombshell. He publishes this paper saying, and I'm quoting here, that Mendel's data was falsified. He's basically accusing the father of genetics of faking his work. I mean, can you imagine? That's a huge deal, a massive claim to make against a scientific legend.
So, the too good evidence. What on earth could have made Fisher say something so bold? Well, the evidence was right there in the numbers. Fisher's whole argument was, incredibly clever. He wasn't saying Mendel's conclusions were wrong. Nope. He was saying the results were actually too perfect. They were too good to be true. They didn't have that little bit of messiness, that random noise you always get in real-world experiments.
Okay, let's break this down. Imagine you flip 100 coins. What are the odds you get exactly 50 heads and 50 tails? It's possible, right? But it's not super likely. You'd probably get something like 48 heads, maybe 53, a little bit of randomness. Now, imagine doing that 84 times in a row, and every single time you get results that are almost perfectly 50-50. At some point, you'd start to think, wait a minute, this isn't just luck. Something's fishy here. And that is exactly what Fisher was looking at with Mendel's data.
So here's Fisher's actual math. He used this thing called a chi-square test, which is basically a way to see how well your data fits your hypothesis. All you need to know is that a high probability here, that last column, means a super close fit. And look at those numbers, 0.95, 0.94, almost 0.999. That means Mendel's data was fitting his own predictions almost perfectly, time after time.
But this is the real kicker. When Fisher put all 84 of Mendel's experiments together, he calculated the odds of getting results this good just by random chance. And the number he got was 0.00007. Let me say that again. That's a 7 in 100,000 chance. It's not just unlikely, it's statistically almost impossible. No wonder he was suspicious.
An unsolved mystery. Yeah? Fisher's math was solid. You couldn't argue with it. So, for decades, this dark cloud just hung over Mendel's legacy. It was this huge, awkward, unsolved problem in the history of science. And we're not talking about a quick debate here. This thing dragged on for over 70 years. After Fisher's paper in 1936, it really picked up steam in the 60s. Scientists wrote over 50 different papers arguing back and forth. Heck, even a book published in 2008 with the title Ending the Mendel-Fisher Controversy basically had to throw its hands up and admit, yeah, we still can't really explain why the data is so good.
People came up with all sorts of theories, right? Maybe it was an assistant who knew what Mendel wanted to see and fudged the numbers. Or maybe Mendel himself just stopped counting when the ratios looked right. Or maybe he tossed out some plants he thought were contaminated. But here's the problem. None of these explanations really held water. They either didn't match the math, or they just ended up accusing Mendel of being a fraud anyway. So the case went completely cold.
The p-value puzzle. So the case was cold for years. And then, in 2010, a couple of researchers decided to look at the data again, but from a totally new angle. And they found something everybody else had missed.
What they did was look at the p-value for every single one of Mendel's 84 experiments. Okay, so what's a p-value? Just think of it like a fit score. A high p-value, something close to 1, means your data is a really nice fit for your theory. A low p-value, close to 0, means it's a pretty bad fit. Simple as.
Now here's the key part. If everything is just up to random chance, those 84 p-values should be all over the place. Like throwing darts at a board. Some should be great fits, some should be terrible, most should be somewhere in the middle. It should be an even random spread. But they weren't. Look at this. This is what Mendel's p-values actually look like. It's completely lopsided. There are way too few low p-values, the bad fits, and a giant pileup of high p-values, the great fits.
In fact, there were twice as many in the good half. So this was just another way of showing what Fisher suspected all along. The data was definitely, weirdly, skewed towards being too good.
A plausible explanation. And you know what's funny? This weird, lopsided pattern, that was the clue. That's what finally cracked this case wide open.
So this 2010 paper came along with a totally new idea. They said, hey, what if this isn't about fraud? What if it's about something we all have? Unconscious bias. They basically asked, what if Mendel, being the super careful scientist he was, just had a tendency to rerun any experiment that looked a little funky? Their model is brilliant because it's so simple. So step 1, Mendel does an experiment. Step 2, he looks at the results. Do they look a bit weird, a bit far from what he expected? In other words, is the p-value really low? If yes, step 3, he thinks, I should probably do that one over. Maybe some stray pollen got in there. And then step 4, he just reports the result from the better of the 2 runs. The amazing thing is, he wouldn't have to do this very often for it to completely change the shape of his final data.
Okay, so remember this table? This was Fisher's original analysis. The big problem was that total probability at the bottom, 0.99993. Just way too high to be believable.
Now look what happens after they applied their unconscious bias model. They ran a simulation where they just redid the worst-fitting experiments every now and then. And wow, look at that total probability. It drops from that crazy 0.9999 down to a totally normal, totally random-looking 0.6577. Just like that, the 2 good data looked completely fine, perfectly believable.
The final verdict, and that right there was the breakthrough. For the first time in over 70 years, someone had come up with a way to explain Mendel's perfect data that was statistically sound and didn't call him a cheater.
The authors of that study really nailed it in their conclusion. They said that an unconscious bias may have been behind the whole process, and that if you accept that, it explains the paradox and ends the controversy at last. So Mendel wasn't a fraud. He was just human, a brilliant, pioneering scientist who was probably, and understandably, guided by his own incredible ideas.
And here's the best part, the thing that makes this explanation so perfect. It turns out Mendel actually wrote about this himself. In his paper, he literally says he repeated one of the experiments because it showed the greatest departure from his theory. He wasn't trying to hide anything. He was just being a good, careful scientist trying to get it right.
So the case of the 2 good data is pretty much closed. Mendel is off the hook. He wasn't a liar, just a human. But that leaves us with a much bigger and maybe more uncomfortable question, right? If unconscious bias could shape the work of a genius like Gregor Mendel, what does that mean for the science we rely on today?